All right, we're being introduced to vectors today. So a vector is just a line segment that has direction. A characteristic of a vector is that it's going to have a length and it's going to have a direction. So a vector is going to have length and direction. So when we have a complex number, complex numbers are often used to represent a vector. So this is an example of a vector. So notice that the notation, there are two capital letters. The first letter is the origin or the initial point. And then the second letter is the terminal point or where it's going to. And then notice that it's not a complete arrow. When you graph a line, you know how you draw an arrow on the end to show that it continues that direction. For a vector, you're not going to draw an arrow, but you're going to draw like a half arrow. So this would be the vector AB. So it starts at A and it ends at B. So this is the initial point, A, and then you have the terminal point, B. So in order to graph a vector, you want to locate the initial point and the terminal point. Then you draw a line segment from the initial point to the terminal point. And then you put a half arrow at the terminal point. This shows that is the end of the vector. All right, so if an initial point is not given, then you just use the origin as your initial point. So let's graph the vector 3 minus 5i. Since an initial point is not given, we're going to assume that the initial point is at the origin. And then to find our terminal point, we'll go to the right 3. 1, 2, 3, because that's our A value. And then we'll go down 5. So 1, 2, 3, 4, 5. So that's our terminal point is 3, 5. Then we'll connect it with a line and then draw a half arrow. Okay, let's do negative 2 minus 3i. So to the left 2 and down 3, that would be our terminal point. We'll connect our initial point with our terminal point and then draw a half arrow. Now we have negative 2 plus 4i. So there's no initial point given, so we'll assume that it's an origin. Then we'll locate our terminal point. So we'll go left 2 for the negative 2, and we'll go up 4 for the plus 4i. And right here is going to be our terminal point. So we'll connect our initial point with our terminal point, and then draw a half arrow to complete the vector. All right, so what complex number is represented by this vector? So we will start at the initial point, which at this is the origin, and we need to figure out the real part, or the A part of our complex number is going to be the distance horizontal from the initial point. So from the initial point, it went horizontally 1, 2, 3 to the left. So that means the first part of the complex number is negative 3. And then it goes up 1, which means that the imaginary part is plus 1i, or plus I. So we would write our complex number as negative 3 plus I. Okay, let's do another one like that. So starting from our initial point, which is the origin, we had to go over 2 to the right, which means that our real part of our complex number is 2. And then we had to go up 1, 2, 3, 4, which means the imaginary part of our complex number is 4i. So we would write this complex number as 2 plus 4i. Here's another one. This one's a little bit more tricky because your initial point is no longer at the origin, it's over here. So from the initial point, you have to figure out how do you get to the terminal point, and then that will tell you what your complex number is represented. So to get to the terminal point from this initial point, we had to go 1, 2, 3, 4 to the right, which means that the real part is 4. And then we had to go up 2, which means our imaginary part is 2i. So the vector represented here would be 4 plus 2i. Okay, so for this one, starting here at our initial point and going to our terminal point, we had to go to the right 1, 2, 3, 4, 5, which means our real part is 5. And then we had to go down 2, which means that our imaginary part is minus 2i, or negative 2i. So that means that our complex number represented here is 5 minus 2i. Okay, so one thing that is an important characteristic of a vector is length. So if you're looking at complex numbers as vectors, remember in the previous lesson we learned how to take an absolute value of a complex number. Well, the absolute value of a complex number is also the length of a vector. So we're going to be taking absolute values again of our complex numbers to find the length of the vectors. And then the other important characteristic of a vector is direction. And direction is usually determined by trigonometry. And that will help you find the direction of a vector. So let's practice. We want to find the length of the vector negative 3 plus 6i. So to find the absolute value, we would do the square root of 3 squared plus 6 squared, which is 9 plus 36, which is 45. And then the square root of 45 simplifies to 3 square roots of 5, which is option 2 here. All right, so now that you know about vectors, vectors can be added together. So they can be added 2 ways. You can either add it graphically or algebraically. So if you're going to add vectors algebraically, it's the same as adding complex numbers. You would add the 3 and 7 together to get 10, and you would add the 4i plus negative 5i together to get negative 1i. So that means your ending vector would be 10 minus I. Graphically, it's a little different. You have to make sure that vectors are head to tail. So when you graph your first vector, wherever your terminal point is of the first vector, that's going to be your initial point of the next vector. So here are the steps to adding vectors graphically. Step 1, you start the first vector at the origin. And then you start the second vector at the head of the first vector. And then the sum is going to be the vector from the origin to the head of the second vector. Let's take a look at what that looks like. So if we wanted to find the sum of these 2 vectors, notice that here's your first vector and here is your second vector. The sum is going to be from the origin to the head of the second vector. So this vector right here would be the solution, or the sum. And as a complex number, that would be negative 1 plus 3i. So that would be the sum of those 2 vectors. So again, if you took this vector, and this is the terminal point or the head of the first vector, and then you put the initial point of the second vector there, and then here's the head or the terminal point of the second vector. And then you go from the origin to the head of the second vector, and that would be the sum vector, or the solution of the sum of the 2 vectors. So as a complex number, that would be 1, 2, 3 minus 2i. So 3 minus 2i would be the sum of those two vectors. All right, we'll do one more. So here's your first vector, and then here's your second vector. The sum would be from the origin to the head of the second vector. So it would be 4 plus 3i would be the sum. Okay, so 4 plus 3i would be the sum of those two vectors. All right, that's all for your introductory lesson on vectors.